All righty. Good afternoon, good morning, and good evening, depending on where you're from. For Mark, already saying good morning, but I know it's afternoon to him right now as well. Another edition of Takeo Tuesday. All right. You're joined right now by myself, Dave Holdorf, and also John Barba, as a listed as Takeo Comfort Solutions, and on his
Oh,
icon right now on the camera. But that's okay. He can adjust that.
I can fix that.
I know he knows how to do that. Yep. So welcome, welcome, welcome for another edition. This is going to be a part two. So we did a couple of weeks ago, we did a start of our VR series circulators. So when I was saying that we were coming out of the basement, meaning that we couldn't have to put those pumps in the basement space, but when the rooms and projects get big for pumps like those are mechanical rooms, as we like to call them. So that's what I meant by that coming out of the basement. Today we're going to continue that, and we're going to show you how to set up and do some of the programming on these circulators as well. So, but before we get started, if you all can take a quick moment, let us know where you're coming from. Just a quick hi, hello, how are you? Drop your name in there, just so we know that everything is working, that one, you can hear me, and two, the presentation, everything looks good so far. So we got Tom from Maine right now. Excellent. We got Corey is jumping in here. Jordan asking a question: will a copy of the presentation slides be provided? Unfortunately, not. No, we do not. We do not share the presentations. However, what you will get in 23 hours time is a link. You'll get an email from us that's going to have a link to this recording, and, to be able to rewatch this video anytime you like. So excellent. Thank you for that, Jordan. All right, we got Mike in New Jersey. We got Laura from Maryland. Excellent. Jet from Las Vegas. Everything sounds good. And Saeed from Texas, and Bob from Kentucky. Excellent. Awesome, guys. This is
Yeah,
really good.
represented from all over the great United States
That's right. That's right.
and the world.
And the world.
Yeah.
That's right. Also, make sure if you have any questions whatsoever, you make sure you ask that question right away. We do not have a question and answer period and say, save them to the end. You ask it immediately. John will find a way to interrupt me as we go through there. And I'll also see the questions. They're popping up on this screen over here as well. So do not be shy to ask any questions. And if it was a question from last week, we'll definitely find a spot to bring that up as well. Ernie from Mississippi. Awesome. Thanks, brother. Robert from Vermont. Mac from Oregon. Wow, we are. And here's our international Gillies. Excellent.
Gilles from Montreal.
Yes.
Bonjour, Gilles.
Yes, I did say that wrong. Correct. I apologize on that one.
Are you New Yorker? What do you know from proper French?
That's right. That's right. So, thanks everybody. Let's get this thing. Anybody got any questions from 2 weeks ago? If you remember, was there anything that was glaring in regards to the circulators that I was going over? Last week we went over the different applications and some of the different settings that you see on the faceplate and how to set those up. Today we're going to do advanced. Some of the advanced controls that are built into these circulators, where you do not need to use an external control in order to make these things do what you want it to do. So, in case you're curious, when we take a look at the VR series, the Circs, we call them VR 15 through VR 30. We do have them in a steel version, and we also do an stainless steel. And these are also NSF hot certified as well on that stainless steel side of things. So, and the designation that we have that we call between VR 15, the VR 15 was originally designed to handle the flow rates on what you would see in 1.5-inch pipe. And so we do VR 15, 20, 25, and 30. But also in between those models, we also have a low, a medium, and a high as well. And I will show you some of that as well. Coming up, I'll show you some of those pump curves. So obviously also the differences other than just the cast iron and stainless, you'll also see by the faceplate, the cast iron circulator would have a black faceplate, and a stainless steel will have a white faceplate there, also with the NSF certification designation on the front side of it as well. So when these things get all insulated, they do come with this insulation jacket that you see as well. But once you insulate the whole project, then you don't know what's behind the insulation. At least you can tell just by looking at the faceplate whether it's going to be a stainless steel or a cast iron model. All right, so our VR15 is broken down into 3 models, IE/6, meaning 3 for cast iron, 3 for stainless steel. The VR15L, M, and H, and the H is going to get you about 50 foot ahead and out to about 125 gallons a minute, whereas the VR15L is getting you around 90 gallons a minute and about 28 foot ahead. And then we jump out to the VR20, which now we're getting to that 180 gallon range up to 50 foot ahead. Then we jump out to the VR25, which is just under 300 gallons a minute and about 60 foot ahead, 65 foot ahead or so. And then you've got the VR30 that's getting us out to 320 gallons a minute and 65 foot ahead. All right, so those are the different models. Now, for example, the VR15L is not just a detuned 15H. These are distinctly different circulators. So this way, when you are choosing, and say, for example, if your design point comes in at 35 gallons a minute and 15 foot ahead, now, could I make a 15H do that? Yes, you could. All right, but you're probably going to operate on the very low end all the time. It's never going to have a lot of range to work with. All right, there is a minimum speed that these pumps are going to operate at, usually around 1100 RPM, as we talked about last week. So you wouldn't want a 15H to do that 35 gallons a minute, 15 foot ahead. 15 foot ahead. The 15L will have a little bit more rangeability, so to speak. Very small changes in the speed of that circulator. Also has very small changes in its flow and head. But meanwhile, you put the 15H in there, small change, drastic changes in the flow and head that it gives you. So, so just watch how you're designing and selecting some of those circulators that you have out there. We're not going to go through sizing and anything like that today. I want to talk about how we start setting these things up today. So, a little bit of review from last week. The faceplate gets us a lot of programming. You can see when this is up and running, it is going to give you the power consumption right at that moment in kilowatts. It gives you the pressure drop in foot ahead. All right, and this will rotate every couple of seconds as it's running. It gives you the flow in gallons per minute. Okay, and it will also give you the RPMs, the speed the circulator is running at that time period. And along the right-hand side, it's giving you the designation of what mode the circulator is operating in, and these are the modes that we talked about last week. The one that is highlighted on the screen right now, that is showing me a fixed speed mode, which means the circulator never changes speed. It would be, say, a zone pump style system or a set of length of pipe going there and back with no other valves in its way, meaning control valves or zone valves. The next one up right here in the middle at the 3 o'clock position is my constant discharge pressure, which now means it's a variable speed circulator when it's running. It will depend upon the system. When valves are opening and closing, it will speed up and slow down. The third one up here, all right, this is going to be our proportional pressure mode. And this is when you have, say, a thermostatic radiator valve, some valves that are constantly modulating. And last week, we did show you several piping applications that would use it as a open-close valve, but you've got that extended header that runs throughout the building itself, and you have those open-close valves. So now we have a proportional pressure. And then the one at the top here is giving us that automatic mode, all right? And the auto mode, what we call take-o-adapt, is now taking into account the proportional pressure and figuring out which curve it's going to operate on. Here, you're programming that curve. This one here then starts to calculate it, but there was a lot of criteria in order to make it. So the take-o-adapt mode is not necessarily the be-all, end-all, as we talked about last week. It is just a mode that we have, and you got to make sure you fit all 3 criteria that we talked about. So if you don't remember, make sure you go and take a look at that video that we put together from 2 weeks ago of the part 1 of the VR circulators.
Dave, it's always important, and I think you did a good job there, so to reinforce with people that when a circulator has an auto mode, and it doesn't matter who makes it, it's not that press the button and everything sizes itself. It operates in very specific parameters, and you have to know what those parameters are to make sure that it fits for your application. Again, it's not that It's not that I just press the button and everything's fine. I don't have to know anything. So many people seem to still make that mistake.
Right, right. You got a set of criteria to make sure it's going to do that for us in our applications. And thank you, John. I almost forgot. I didn't want to jump off this screen yet. It does also have a night mode. So when you see this picture of the moon, this night mode means the circulator is going to go into an energy efficient mode and drop its speed. However, we don't typically do setback the way this circulator is looking for. This circulator, because as you guys know, Takeo is an international company, so we make sure this circulator works on both sides of the pond. So the night mode for this circulator means when the water temperature drops 20 degrees, all right, the delivery water temperature drops 20 degrees in less than an hour, the circulator will start to run at a slower, reduced speed. All right, we typically do setback here in North America by air temperature, not water temperature. And if we are doing any type of outdoor reset in our system, our night setback is going to be at nighttime when nobody's in the building, but it also gets colder at that point. So the water temperature will actually increase if we're doing any type of weather compensation for our building. And then on the right-hand side, this display is just a general light to give you an idea of the approximate speed of the circulator. It doesn't mean it's running fourth speed here. It's somewhere between 60% and 75% speed of the circulator itself. So it's just to give you a quick visual representation of where the pump might be in its size that it's running. So that's what you're going to see on the faceplate of the circulator when it's up and running. All right, and like I said, here's those operating modes again that I talked about. I'm sorry, let me go back a slide. So here you can see the fixed speed mode. All right, you're adjusting it based upon RPM of the circulator itself. All right, here's your constant pressure mode. All right, where we're adjusting the maximum head that circulator is going to operate on, and we'll change its speeds as the flow changes. All right, and maintain a constant discharge pressure. Here's our proportional pressure mode. All right, so this one here will slide up and down as your valves are slowly opening and closing. And then there is our auto mode, which happens to be the default mode of the circulator itself. And there's the night setback. All right, so just a little bit of review from last week. Let's jump in there. So you turn this thing on. You power it up for the first time, and we're going to talk about how we hook up our power to this thing too. It is going to be in the default mode of Takeo Adapt, and it's going to be running. All right, so you put power to this circulator, it's going to start running. All right, your motor's going to start spinning, so make sure at that point you are prepared to have water in this system as soon as you put power to this thing. If not, you need to make sure you read the instructions a little bit further in order to make sure you power this thing down. Bless you.
Oh, sorry about that. Didn't realize.
I thought I was muted. Yes.
Didn't realize I had a hot mic there. Sorry, people.
So you can turn the pump off, meaning you can disable, you could turn it off and not run. So what you do is you press the down arrow on the circulator itself for 5 seconds, and it will say OFF on the display, and the circulator stops running. So that is really useful if you wanted to start programming this circulator. All right, and you don't have everything all done just yet. You put power to it. Make sure that there's water in the system. Okay, so that is very, very important. All you need to do is to get it back running again. You just touch the down arrow again. You don't have to hold it for 5 seconds. You just touch it, and the circulator will go back in the Takeo Adapt mode. Again, it's going to be running in the default mode until you change those settings. Now, this is important. All right, we do not want to power down this circulator more than 8 times in an hour. All right, so you want to be able to you could power it down more than 8 times by the faceplate, but you don't want to shut the power down. All right, so we got to be careful on what we're doing here. So when we're hooking these things up, this circulator can be connected to one of our switching relays that we talked about a couple of weeks ago. All right, but that switching relay kills the power to this, so you don't want to do it. When I say it can be, meaning the power that this thing can do at the 120 volt versions, the smaller ones, physically can be connected to it, it would turn on and off, but the circulator does not like that. So we are not going to hook these up to a switching relay. We do not want to do that here. All right, because we don't want to see more than 8 starts an hour. So when you are programming, all right, the fixed speed setting. So if let's say we're in the fixed speed mode, what we are going to do and change that to change the mode to get it out of the auto mode, you're going to hold down the set button for 3 seconds. All right. Now your speed here is going to be between 1100 and 4400. That's the range this circulator will work at. So that one light all the way down here is going to be starting at 1100, and 44 is going to be all the way up here. And if I remember correctly, it was around 3800 RPM to 44 was the 5th speed. And I think 1100 to I think it was around 1500 was the bottom light. All right. And anywhere in between. So, but what we need to know in fixed speed mode, what you need to know is your flow and head. All right. Yes, it gives you a show of what the gallons per minute is, but when setting this circulator up in that fixed speed, you need to know your flow and head. And what you're going to do is you're going to program an RPM, let the circulator run, and then see what the flow is showing you, and then come back and change the speed if you need to, if that makes sense. All right. So what you're going to do is hold down the set button for 3 seconds, which then gets the mode flashing. So once you see the mode flashing here, then you hit the up arrow until the mode that you want is flashing. Once it's flashing, then you hit set again. As soon as you hit set, then it gives you the option to change the speeds. And you'll see here right now it's showing you 2.5 or 2500 RPM the circulator is going to be running at the time. So you're going to hit the up and down arrow to choose to change your speed. And this is critical. This is very critical right now. Press set again, because if you do not hit that set button, it will go back to that default RPM that it was sitting at. Say right now that would stay at 2,500 RPM. And it would, if you needed it to run at 44, it's going to go back to that. So remember, hit that set again, because if you don't hit anything, it just sits there and then eventually goes out of the programming mode. Okay. And now it's back into the run mode because nothing was saved. All right. And it's going to save it in that RPM mode. So I've had a couple of phone calls on that. It's not staying at 4,400 RPM. It's running at 25. That last set was the important part. All right. So just got to remember that. So, sorry, that's your fixed speed. Done. Again, that's your flow and head. We talked about those applications last week. Now, you program it, you set it up, you're done. But it's not in your house. It's somebody else's house. It's another project. It's another building. And you don't want people to mess around when they walk by and say, oh, well, I want that pump to run faster, or I want it to run slower. I'm going to change the modes or whatever it is. You can lock it out. All right. So if they, what you can do is you hold down the down arrow and the set button for 5 seconds. Hold them both down at the same time. 5 seconds, LOC will show up on the screen. All right. Therefore, whenever anybody walks up to it to try to change the settings, it just says LOC on there. They have to know, hold the 5 seconds again, the down and set button at the same time will unlock it. So it's a protection mode to make sure that people aren't messing around with the circulator after you have set it up. All right. Does that make sense out there? How we doing? How we doing, JB?
Everybody's doing dandy. Haven't had any questions yet, but I'm sure there will be once we get into some of the wiring stuff. But yeah, folks, any questions you have, just type them on in, and we will we'll do our very best to answer them.
All right. Awesome. All right. Here's the fun part, right? Let's get into wiring this sucker. So this is what we see inside the electrical box. So your power connectors are going to be over here on the left-hand side. You can see the line, neutral, and ground. All right, we do have an external relay, so we can actually go ahead and send power someplace else. We do have a relay that's here. The analog switch over here, or this analog terminal block here, there will be a jumper defaulted in the circulator here across that set 1 and set 3, or the run terminal, which means that's why the circulator was running, because we have this jumper that's automatically installed in there for us. And then over here on the top left, top right-hand side, you're going to see a Cat5 connection. So the Cat5 connection here is for doing some advanced programming and monitoring of this circulator itself. So we're going to address that in a little bit. And then we have this mode dial. So this mode dial gives us a few other settings based upon how we use this terminal block here as well.
I do have a question there, Dave, that came in regarding
Okay.
dry contacts. What's the rating?
All right, on this relay here, yes, it is going to be a dry contact. And off the top of my head, unfortunately, I do not remember, all right, what the rating is, but it is a dry contact. You do have your normally open and a normally closed a single pole double throw switch that you have here. So that's what we got built into this relay. But off the top of my head, I'm sorry, I do not remember the rating. I haven't used it in too many applications, haven't found something to use it for just yet that would need to. I think the only time I saw somebody use it was they ran another light to it, all right, and just, you know, opened and closed the switch so they could see the light remotely saying, hey, that pump is running. But that was the only time I did anything with it right now. All right, so bringing line voltage into this circulator. If you looked at the instruction sheets for this circulator, we have these listed between 110 volt up to 277. Same circulator, but not all of them are the 110 to I'm sorry, not 277. I was thinking of a zone valve for a second. 240 volt. All right, so you bring your line voltage in to our circulator here. You've got your circuit breaker, you got your switches, a safety switch there. Okay. Now, when we take a look at the models here, and this is where I've seen some confusion, and again, a couple of phone calls that have come in and say, hey man, my circulator's not running, it's really slow. You know, I got VR15s on here, and they went with the VR15H. So you'll see here the VR15 through 20M. Say, oh, look at that, these are all 110s and everything else is 200 to 240. All right, however, the VR15H is a 200 to 240 circulator, not a 110 voltage. So you put 110 to the 15H and it's not going to give you the full speed you're looking for. So these are not different models. The beauty of this circulator is depending on what you've got there is how you can hook it up. So the VR15L, you can have 110 or you could have up to 240. You could have 200, 208. You can just drop it right into the terminals and rock and roll and you're ready to go. All right, but just make sure you pay attention to which model here and what power you can run to those circulators. So that's been, and remember again, these are all single phase. It is not a three-phase pump. These are all single phase ECM wet rotor circulators. So your default configuration, like I talked about, you've got your jumper across set 1 and set 3 here, okay? You're going to bring line voltage in. The default mode dial is going to have is 1. Just leave that alone. And whenever we change any of the settings on this mode dial, and there's a couple of times that we're going to, you have to make sure you power down the circulator, meaning remove power. All right, this mode dial is only red on startup. It is not read continuously, and there's a lot of products out there that only read configurations on a startup. It's not a continuous. So this circulator we've been doing now for almost 14 years, and we have this mode dial. Just remember, all right, when you want to change settings and use one of the other modes, the only other modes you're really using is 1, 2, and I think I did something with 0. All right, and that's it. But when you change that mode, power down, power it back up again.
Dave, I was able
Yes,
to
sir.
find out the rating on that relay. It's a 3 amp, 230 volt.
Okay, excellent.
It's amazing what you can find in the submittal data sheets.
Yes, sir. I know, right? You know, writing stuff down in a manual, that's crazy.
Hell yes.
Anyways, so here we bring our line voltage in, and like I said, we do not want to put a switch on this that you're going to use automatically. Yes, you could put a switch on the wall to power it down, but it's not going to be, we're not going to switch the power on and off when there's a call for heat. Okay, so that's what we don't want to do. So yes, have your service switch, just not the switch for powering this thing on and off. when you do want to switch this on and off, you have some sort of external signal coming in to tell it to run, you're going to remove that jumper across set 1 and set 3, all right? And here your relay ties into here, your dry contact, all right? Here you're going to have that switch tie in, non-powered switch to this terminals, and you'll have that operation that we're looking for, okay? So that's the biggest thing I've run into, not the biggest, but that has been a big thing on why circulators have been messing up out there as we do it. So anyway, so that's if you need some sort of external control tied into here. Now, here's the fun stuff that you got outside of the faceplate of programming, right? We do those faceplate programming and you want to do a little bit more, all right? Now you could take your laptop, tie it into the circulator itself, and get a little bit more details and a few more operations that you can't get from the faceplate. What we're going to do is tie in with a standard Cat5 cable. So you got that port on the back side of the under the electrical box in here, tie it directly into a computer. There is no app, there is no special software that you need to download. It is just using your standard web browser. So any web browser you've got on your laptop, any computer that you've got, so whether it's Firefox, Chrome, Edge, whichever ones that are out there right now, Safari, you open up that web browser and you type in two things, or one of two things. So you type in the words OOE or the IP address of the circulator, and every circulator has this IP address of 192.168.0.245. They all come that way out of the box from the factory. You type in any one of those things. Now, you do not need to be online, all right, because yes, we're going to find these circulators installed in a mechanical room. There's not a lot of Wi-Fi down there. You don't need to be, nor do I want you to be, all right? And what you're going to do there is now you're going to open up that web page and it's going to give you that advanced operation of the circulator itself. So you tie in, like I said, with that Cat5 connection. However, I do know this on my laptop, and some of you guys out there, you may not know that, you may not have a Cat5 port on your computer. All right, get your hands on one of these things. All right, very simple, very inexpensive. All right, plugs into your USB port and your Cat5 connection there gets your computer online with it. All right, I did see a question here come in from Chet. Is this a standard cable or reverse? So the reverse is what we call a crossover cable. All right, so no, this is going to be a standard Cat5 connection when I am communicating. There is an instance that I need to use that crossover cable, and I'll get to that in a minute, Chet. So excellent, excellent question out there. Whoops. All right, so once you tie in, all right, and this is the screen that pops up. It's going to just say, welcome, you're connected to whatever size circulator you have, named OOE, and it's going to give you the operation mode. Right now, this circulator is powered down, and this is just going to be what is happening at the moment. So you'll see the circulator set up in constant pressure mode. It is not spinning, but the power head is powered, so it's only consuming 1 watt out of a maximum for this model size of 180 watts. Flow head, RPM efficiencies, and your signals coming in, and no error codes. All right, so there's no error codes on here. You're good to go. All right, so this is just your quick overview. Now, you want to do some settings. We click on the pump tab. All right, and then now you could program this circulator from here compared to the faceplate. So yes, you can do the settings from the faceplate and go through the buttons themselves, or you can do it from here, your choice. Same thing, does both. I still suggest if you program via the faceplate, log in, do some screenshots, and this way you capture how you left the circulator as well, rather than taking pictures on my cell phone and then you come back to it 3 years ago and you're sitting there scrolling through your phone. Yeah, I'm going to get there. It's here somewhere. It's coming. All right. Now, at least you got a screenshot. You put it in the file. You're good to go. All right. So you can see here, and it also tries to make it where you can't choose incorrect settings for one application versus the other. So right now you choose the operation mode of constant speed, and you can see right below that max head is grayed out, meaning you can't change the head of the circulator itself, because that's not the mode you're in. You have the option to change your RPMs. So that's why this one is lit up. Now, Q proportional here means I can change that proportional setting. So 2 weeks ago, we talked about the proportional is set on a 50% incline or decline. All right, here you get to change that proportion. All right, so if you need it to be steeper or you need it to be flatter, you can do that here. And here's your checkbox for your night mode. All right, so you just choose it and just remember, choose those RPMs in 100 RPM increments and make sure you click save. That's the same thing from the faceplate as you hit that set button again. So you got to hit that save button on the screens themselves. Otherwise, it just goes back to where it was before.
Dave, we're about halfway through here, and I just wanted to check in with everybody out there in webinar land. How are we doing? How's the pace? Just chime in with your thoughts, and again, great time to ask questions as we go through the app setup. But if you guys want to just chime in and make sure you're still with us and let us know what you're thinking so far. We appreciate that.
Awesome. If you're still there too, yes.
I'm still here. I'm all over.
All right. Excellent. Robert, awesome. Ernie, great. All right. And actually, I'm curious to a lot of you that are out here, is this the first time you've seen this circulator? Because I know for Take-O Tuesday that John and I do, we're usually talking our smaller OOE circulators like the 7E and the 15E and whatnot. But have you seen this circulator? So Will's going first time. All right. All right, not bad. Because yeah, it's one of those things that not a lot of people have seen out there. And this circulator falls, like I said, a lot of ranges. So yeah, we always talk about those residential settings. Does this show up in a residential house? Well, yeah, people lived in it, but it's not necessarily a house, right? It might be 20,000 square foot starter castle where you need to put this in. But it is a house. So excellent. Excellent. Thanks, Will. All right. So again, make sure you hit save. All right. Now, another really cool operation of this circulator is that you can use this in twin pump operation, which means you can put 2 pumps in and you have automatic operation and you don't need an external controller. You're actually just running a cable between the 2 circulators. All right, and that's it, and we have everything built in. So what can you do in the twin pump mode? Well, you can have one circulator as backup, and we run into that quite often. We want to have a second circulator automatically turn on if one fails, if it stops working. So you can do that backup operation, and that will kick in really fast. So whatever it is, this one's saying overload, but what happens is the second pump kicks in a quick 15 to 20 seconds or so. You could also do cascade operation. So your cascade is going to be, hey, I came up with a project and I need it to flow 300 gallons a minute. And as you guys know, that's pretty darn close to the VR30 maximum flow that it's going to do. But what if I were to have 2 pumps designed to do 150 gallons each? Okay, so now you're cutting down your costs on your circulators and also your power consumption. Instead of having 1 pump to do 300 gallons, I got 2 pumps that can do 150 gallons. So you got 2 smaller pumps here, and 1 pump starts to ramp up, all right, and once it starts getting close to that top, the second one kicks in. So, and then the first one's actually going to slow down, and then they both start to ramp up. All right, so it's all about trying to get that energy efficiency going on at the same time, because you've got a system that has a variable flow happening. It's not always the same flow continuously. So as it gets colder outside, that's when we need to ramp up with both pumps. So that's your cascade operation that we have built in. Okay. Now, remembering though, when you are sizing them, obviously they both need to be the same size, and you can't use Take-O Adapt in either one of them there. You're going to use either fixed speed operation or proportional pressure, or you're going to do in constant discharge pressure. And what we'll also do is do an automatic alternate, all right, which means not every single time do they turn on. And when you have those 2 pumps here, twin pumps, we're always running pump 1 all the time, and maybe pump 2 never turns on until it's absolutely needed when pump 1 never operated. So what we do is we automatically, after 24 hours of runtime, switch the pumps. All right. Now remember, that's runtime, not of time. I've had that phone call a couple of times where guys were out at job sites and I was just here yesterday and pump one was running. I'm here today and pump one is still running. Well, did the signal ever stop? Well, yeah. So yes, there's a time the pump shuts down. So remember, it's 24 hours of runtime, and that is non-adjustable. So there is no way to change that runtime in the circulator themselves. So this way you have both circulators getting an equal life out of them, and making sure the second one is always going to be in operation. You never want that first one to be taking over his life and running for 10 years, and all of a sudden one day, hey, let's kick out, turn on the second one, and the second one doesn't run because it's never turned on in 10 years. So that's automatically built into the circulators themselves.
Even pumps don't like being sidekicks, right? They
That's
want to
right.
play too. Everybody
They
wants
want
to play.
too. That's right. Yep. You know, this was the best picture I can come up with, other than trying to find a project that had two pumps sitting there next to each other. So
I
I
think
had
that tells the story just fine.
yeah, yeah.
I mean,
Yep.
I have trouble telling those two guys apart.
I know. Yeah. All right. So doing your setup in twin pump operation. So now you're going to come to the network tab, and you are going to have to start playing with the IP address of the circulators themselves. So, like I said before, the default is going to be the 192.168.0.245. It does also have a name of the circulator, right? Remember, before I said they all have OOE as their name. You could change the name if you want to. You don't have to. I suggest leaving it as OOE because who's going to remember 192.168.0.245 when you log in? Because you took out a Sharpie and you wrote on the outside of the circulator 10 years ago. You come back, you take a look at it, and you can't find the Sharpie, all right, what you wrote down on there or whatever, right? So if you leave it OOE, you'll be fine and you can log in. All right, obviously you're disconnecting the Cat 5, right? So you got to take that Cat 5 out of it so you can see that pump, and log into it. So what you're going to do, all right, remember pump one has that 245, that's your IP address listed here. When you want to talk to a second circulator, you come all the way down to the tab that says twin pump, and you type in 192.168.0.246 is my suggestion. You could put anything you want there, all right? I would just make it 246, or you can make it 244, whichever one, all right, is your second circulator. Probably go 246 because just count the numbers going upwards, all right? So, and then make sure you hit save. Again, make sure you hit save. Now you're plugged into pump number one. Now what you have to do is take your Cat 5 out, go into pump number two, change the IP address of that one to 246 now. So the default, that was 245, you're changing to 246. And then you come down to the twin pump mode, and it will be blank, and you're going to have to type in the 192.168.0.245. So this way it knows to go back to that one. All right. And then, of course, hit save. All right. Remember to hit save. Okay. And this, as Chet was asking before, this is the point when you want to use a crossover cable. So once you're done, you disconnect your cable, all right, out of there, and you're going to run a crossover cable from pump one to pump two. Crossover cable just means the four wires in the middle of your Cat 5 cable are reversed, okay? So yes, you're going to have the electrician or the IT guy on site to be able to make those cables anyhow. So just make sure it's a crossover cable, because then it doesn't communicate properly. It will never see the second circ. Okay. So very important on that side of things.
These are little things you never really think of when you're going into this thing, that it's a different kind of a Cat 5 cable. So, you know, it's an important point to remember.
Right. And even if you were using standard Cat 5 cables, you're still going to have to make them on site. All right, because as you put the wires through the terminals, they're not going to have the ends on them. So you got to push the wire through. The ends are still going to be made on site. Just remember, they're going to be crossovers there, and you can do a standard Cat 5. Now, here's the other thing that I've done. for those of you, some of my service guys here, my install guys, what you can do instead of running with a Cat5 cable and plugging in, you can get your hands on a small Wi-Fi router. All right, it's a little small. I mean, not a router, a Wi-Fi switch, which basically, you know, might have and I've got one floating around my house that I used to use for the internet Wi-Fi in my building. Got my router, then you've got your switch. So I took that old switch, all right, I created my own little Wi-Fi network out of it, not connected to the internet, and then therefore standard Cat5 cable from pump 1, from pump 2, and then my computer connects to that wirelessly, and you're good to go. All right, so you could do something like that as well, so you can see both pumps at the same time, and you just type in the different IP address rather than moving cables all the time. You can just create your own network while you're there. Again, doesn't need to be online. You don't need to find any Wi-Fi. You're creating your own wireless network, if that makes any sense. So, I used to have a little setup bag when I went to some of these job sites, and I kept that in there because some guys just didn't have the Cat5 and they wanted to learn how to use the software, and they didn't have a Cat5 port on their computer. So, excellent. All right. Finishing the twin pump operation. All right, we did that over there. Here's where you have to get into the mode dial. All right, and you do have to change the mode dial, so you will gonna have to power these pumps down. So you're going to turn the mode dial to 8. All right, it doesn't stay there. Cycle the power down. That says, all right, now when it powers back up again, all right, you turn the mode dial to 1. All right, we start going into that mode. Cycle the power down again for 30 seconds. All right, leave it in mode 1, and then you're good to go in the twin pump setup mode. So it has to go to 8, power down, turn it to 1, power down again. All right, and then you're all set to go in twin pump mode. It does know to communicate between the 2 circulators. Okay, and then you run your Cat5. So, whoa, sorry about that. Went too far. I hit some buttons here. All right, now confirm your operation before you split. All right, making sure. And you know, when you start looking at these Cat5 ports, I learned something a couple of years ago, that those lights actually have meaning to them. All right, so when you plug in and that green light comes on, that means there's communication between both ends of the wire. All right, there's something on both ends of it, but it doesn't mean you're done. All right, because when you go to the orange light, all right, you're going to see that random flashing. So you should see a permanent green, but then you're going to see random flashing of the orange light. That means we're communicating between 2 devices. All right, if you don't see orange, but you got green, all right, well, we got some communication that's happening, but they're not sending backwards. All right, so they're not talking to each other. So confirm the LED lights that are on the circulator itself. Very, very important. All right, now you want to make sure it's doing what it's doing before you leave. Turn on pump 1, and then make sure that pump 2 is inactive. The faceplate should be lit up. All right, so it should have power on the faceplate, but it should be all zeros. All right, as it scrolls through, and you'll see that pump number 1 is running, and you should have some numbers on there. Now what I want you to do is physically power down pump number 1. So we do have that service switch right next to the circ. Power it down. Make sure you leave the service switch. So you want 2 separate service switches. Yeah, I ran into that before too. 2 separate service switches. Turn off pump 1. Pump number 2 should kick on in 10 to 15 seconds. All right. If it doesn't, confirm your connections on what you got going on. All right, and then do it in reverse. All right, now pump number 2 is running. Put the switch back on to pump number 1. Pump number 1 starts running. I mean, is going to be inactive, but you'll see it lit up. Now kill the power to pump number 2. All right, see the pump shut off. It should automatically jump back over to pump number 1. So just confirm that operation before you leave. And while you're still logged in, all right, go ahead and take all those screenshots and making sure that you can see these circulators running before you leave the job site. All right, I always like a little bit of, you know, protection or a confirmation and verification. All right, that these things are running the way you want them to when you left. Okay, very, very important. All right, Another mode that we're going to have built into this circulator that is probably more of the more common functions, like that twin pump is probably by far the most popular. 0 to 10 is now another control feature that we have built in here, where we're going to have a signal from something else to tell us what speed to run at. So there's going to be an advanced building management system that's going to tell us what to do. All right, so you might have that opportunity, like I show in the picture here. Hey, 10's not enough. I need it to run to 11.
You need a different
And
dial.
I can't do it as well, John, so you'll have to do the accent for me.
It has to go to 11, you see. 11, it's one louder.
It's one louder. That's right, it's one letter. Special amps were made. They go to 11.
Yes, and that's it. Right, that's right. Hey, we got a question from Chet. If you turn off the power, how do the pumps communicate?
That's exactly right. It's not. So that's why it knows to kick on the second circulator that's powered, right? So you're only turning off the power to one. So that's how we're testing it out in the field. If the circulator were to seize up or something or die, it knows it's not spinning. Exactly. So it does have a lot of diagnostic data that's going on here. There is a whole bunch of error codes that could also show up on the faceplate, and we do have that listed out in the instruction guide. So, but we're not, like I said, the power is going to be individual switches to each pump. We don't want to put them on one switch, put each pump on its own service switch. You kill the power, it lost communication. Something happened to pump one, pump two automatically kicks in. So that's what we got going on there. So excellent question, Chet. Thank you very much. All right, so your 0 to 10 here is now, and if you're not familiar with 0 to 10, 0 to 10 means we're going to send a signal across a pair of wires, all right? And if the signal is 10 volts across that wire, that means make the pump run 100% speed. If there's 5 volts that go across the wire, run at 50% speed, all right? And we have a couple of different ways that we're going to accept that 0 to 10 input based upon the equipment that might be sending us that signal. And there are some boiler manufacturers that do have a 0 to 10 volt output to go tell the circulator what speed to run at, so the boiler is the most efficient that it can be at the time. So it might be looking at a delta T across the heat exchanger to add the efficiency to the system, because it doesn't want to run full speed all the time, because you're not taking everything out of the boiler all the time. So let's slow the circulator down, let's gain the most of efficiency, let's condense when it's supposed to, and maintain that condensing. So now in mode dial, that mode dial again that I was showing you before, mode number 1 shows our 0 to 10 signal here. And again, this is all going to be dependent upon the equipment that's sending the signal into us. So we're going to have to verify that data from that manufacturer. So for example, here's mode 1, which means once you get down to 3 volts, it's going to give you a steady speed of the circulator itself until it gets down to less than 1 volt, and then the circulator shuts off. And then it waits until the voltage is above 2 volts. Then it has a minimum speed that you would set it for. Then it operates that until it gets to 3 volts, and then we operate on that line. Or actually, I should look at it this way if you're looking at the screen compared to what I see on the screen. Then mode number 2 just brings us all the way down to a half a volt, all right, and then maintains a minimum speed of the circulator, never really shuts it off, all right? So you have to know what signal we want to bring into the circulator based upon the equipment that's sending that signal. So I couldn't tell you one versus the other. It's just coming from those manufacturers themselves what that device is telling us to do. So when you are in mode 1 here, like I said, this is the factory default mode. Here's your 0 to 10. So of course that jumper cross comes off between set 1 and set 3. We put the 0 to 10 volt signal across the board here. And now we're going to have the circulator respond to that as it speeds up and slows down as you get that signal coming into the circulator itself. Okay. So that's the simple wiring that's going to come into the circulator itself. Okay. In mode 2 now says, all right, you're going to have also an on-off switch, all right, because we had an on-off before, All right, I'll come back to mode 1 for a second. All right, we go down to 0. All right, well, once we get below 1 volt, circulator shuts off. So we do have a mode here to tell the pump to stop running. In mode 2, since we have a minimum speed that we're going to make the circulator, now we have a second external switch coming in, an end switch coming in to tell us to turn on. All right, so you've got 2 things happening here. You have 0 to 10 and an end switch coming into here. And this is going to take that dial, put it into mode 2. All right, so now we have our external enable. All right, now what we have to remember here on this end switch coming in, that there is no power here, absolutely 0 power. There are some of the boiler manufacturers out there that operate in this mode. They do have a switch and a 0 to 10 coming out of it. And if you put power across that terminal here, if you go across set 1 and set 3 with that switch, all right, we are going to let the magic smoke out of the circulator, and that circuit board gets fried, and we have to replace just the circuit board, so which is nice. All right, you don't have to change out the whole pump, but we do have a circuit board that does need to be changed out. All right, and if you want to find out how we knew this from that manufacturer, we'll call my friend Jason, who had to do it 16 times in one day. 8 pumps came out of a project, you know, so yeah, or the circuit boards had to change out, so yeah.
So the lesson there is don't connect. This is not where you connect your power terminals from your from an SR control. So
that is correct as well, right? Because that would be 120 volts here, right?
Yeah, it'd be 120 volts, and that wouldn't be good either.
Right, right. So this is going to be strictly dry contact, 0 power on these 2 wires that go across set 1 and set 3. Okay. And that, ladies and gentlemen, concludes our class for the day. All right. So that was everything that I talked about in the 80% rule. There's a few other things, and the circulator does have BACnet built in as well. All right. I don't get involved myself too much in BACnet protocol and programming, but there's a whole bunch of pages in there on that BACnet that you have in order to have that communication to your systems themselves. And if you have any questions with that whatsoever, please do not hesitate to reach out to our technical services team and ask about some of that BACnet programming and what you got going on here. So that falls just outside a little bit of my realm here. I don't, I'm not saying I can't learn it, but I think if I did, I'm going to have to start forgetting things like my kids' names. So
random access memory almost full. Is that what we're saying? Yeah, there you go.
More or less. Yeah. Yeah. What happened to my hair? I pushed all my hair out. So no.
There you go. There you go. Then why do I still have mine? Never mind.
Yeah.
Question for you, Dave. We talked a little bit about this 2 weeks ago, but I wanted to get back on this topic. Is what is the importance of water quality when it comes to the VR circulators in particular?
So water quality, good conversation to have. And you know what? It's not just in regards to this circulator. I think it's systems in general. Now the circulator will give us a couple of error codes when it starts to explore or experience poor water quality. Unfortunately, we start to interpret those error codes as something else other than that. And the first one is going to start saying it's an amp reading, all right, that it's taken too much power, all right, or the overload protection that we have built in. And you see overload and you're like, wait a minute here, what's overload? And you go and you check your power coming into the circulator and you'll say, well, no, my power's where it's supposed to be. I got all the right signals coming into this thing. What it means is it's taken harder to turn, all right? And since this is a wet rotor circulator, right, we're using the water that we're pumping to lubricate and cool the bearings. But also, as we talked about with an ECM circulator, we have a permanent magnet as the rotor part, all right? And if that water is really dirty, all right, we could have started attracting some of that black iron oxide or magnetite that's in the water itself, and it's going to put a little more resistance on that impeller on the inside and the rotor itself to start spinning. So those error codes, and they start to compound themselves. By the time you get to the 3rd error code, that's the overload. So it does start experiencing it. Pay attention to those, because the first error code that pops up, people look at it and it says, okay, and the circuit still runs and it keeps doing what it's supposed to do. All right, well, nothing I need to worry about. No, it's a warning at this point. All right, so water quality, in my opinion, yes, our tolerances are getting tighter. All right, it's not that we're making stuff cheaper. It's just that tolerances are tighter because we need to hit certain efficiencies. All right, this pump needs to operate in a certain efficiency range. In order for us to do that, we have those tolerances that we have to build it to. We can't be sloppy and loose like we could do in some of our standard AC circulators. Now when we get into an ECM, we have to manufacture it that way to hit those numbers. So it's not that they're cheaper. It's just, hey, man, it's just not the same anymore, right?
Right.
So we got to make sure we pay attention to water quality in here.
Got a great question from Chet. In the 0 to 10 mode, does the switch enable the 0 to 10 control, or does the pump go to 100%?
In that mode 2 with the switch, it just says, hey, now it gives you the opportunity to turn on. So if the switch was open and you had 5 volts going across that signal, the circulator's off. So you have to have voltage and you have to have the switch closed in order for that pump to turn on. So so that's in 0 to 10 mode 2. Yes.
All right. Remember our switches. There's always power to the circulator, and then we're just the switch is simply to say, well, run.
Yeah,
Tell
exactly.
the impeller to go round and round or not.
Right. If it's a boiler pump, the boiler's off. If the boiler's off, I don't need the pump to run. Right. So that's where that switch would open up and say, all right, shut off, because at this moment, maybe there was a signal coming in to tell the boiler to turn on from somebody else. Right. Or in other words, an enable switch. Correct. Yep. There we go. That's an enable, then to use the 0 to 10, whatever signal it's operating in. Right. Yep.
What 0 to 10 voltage will turn off the pump?
In mode 2, nothing. Mode 2 is going to maintain a minimum. So if you have that dial switch in mode 2, it runs a minimum speed, all right, until the switch opens, and then the switch opens and it kills the pump. In mode 1, as soon as you get below 1 volt signal, circulator shuts off. All right, so it's the communication protocol from the device that's telling it what to do.
Very good, very good. It will disable the pump.
Disable. There we go. Yeah.
Enable, disable. Chet, you've
better words. Yes, better
you
words.
have updated our nomenclature. We have our own phraseology, but disable and enable basically tell the story very accurately. That's good stuff.
I will have to go through and change this presentation ever so slightly, and I will put your name on every slide that I do that to, Chet. Thank you.
There you go. And Steve
Not
has a follow-up.
Not get any royalties out of it, but I'll put your name there. Thanks.
Steve's follow-up is what is the difference between mode 1 and mode 2?
All right, I'll come back. So here your mode 2. All right, here's your mode 1 versus mode 2. It's going to be that 0 to 10 signal coming in. So mode 1 says there's a minimum speed once you get to a 3 volt signal. So you don't want so there are some boilers and some equipment out there that don't like to have zero flow if they're still flowing, going through the heat exchanger. So here there's a minimum flow rate that has to go through that heat exchanger in order to extract those BTUs out of the water or out of the flame, right? So that's where you get to that mode 3 volts and say, all right, I don't want to go any slower than this because otherwise you're going to mess me up in my heat exchanger. All right, my delta T becomes too wide, all right, at that point. And you'll get hot spots and whatnot. And then therefore, once you get down to 1 volt and below, then it shuts off. So you have a minimum speed the pump runs at. That's your mode 1. Mode 2 is a minimum that you're programming here. All right, and it never shuts off completely except for the on-off enable switch coming in. So mode 1 does not need an enable switch. It does it via the 0 to 10 signal. Mode 2 does have to have an enable switch. So excellent question, Darren. Thank you very much.
Yeah, Chet's after a copyright here for his enable. I think those words existed before you came along, Chet. Just saying.
That's right. Yep.
The fact that we couldn't think of them at the drop of it doesn't really speak well for us, but those words have been around for a
while. Just to confirm, mode 1 does not need switch closed to run. Correct. Yep. There you go, Darren. Awesome. Awesome. All right, everybody. That's all I got today. Thank you very much. We are at the end of our time. Look at that, JB. Almost in an hour exactly.
Just perfect. Absolutely perfect.
Yes.
Stunning if I do say so myself.
Now
we're going to see. Go ahead.
Go ahead.
Now we're going to see each other tomorrow tomorrow
we will.
evening. I was mistaken. Tomorrow night will be the 99th episode of Takeo After Dark. We were thinking it was the 100th, but we did go back and count. Tomorrow night is the 99th episode of Takeo After Dark. So go to the Takeo website and sign up for Takeo After Dark if you haven't already. And it's the last episode of our summer season, of our spring season.
Yep.
Summer season, we're going to start up again in July, and the first episode of our summer season will be episode 100. And we're going to have some pretty cool stuff going on. It's not only the 100th episode of Takeo After Dark, it's the 50th anniversary of the Takeo 007 and the 10th anniversary of the 007E ECM circulator. So I'm not a betting man by nature, Dave, but if I were to lay down some money, I'd lay down some money on some fairly substantial giveaways for our 100th episode of Takeo After Dark. I'm not saying, I'm just saying.
Well, that's what Robert's asking. Do we all now? Are you saying, is there a chance to win one, or does everybody get one?
There will be a chance to win one. There will be a chance to win several. I think we're going to have quite a few circulators on to give away that night, and it's going to be a bit of a celebration. And we're going to be celebrating some other stuff too with that, maybe a new delivery technique and modes of you consuming this webinar. So
yes, so definitely.
It's going to be a big deal. Going to be a seriously big deal.
Yeah, 100 episodes. Takeo After Dark, man.
I know. We've been doing this. We've been doing this a long time, brother. And
when you
5 years,
session was anywhere between 4 and 8 classes.
Yeah.
How many sessions we've done? It's amazing. So, so Takeo After Dark tomorrow night, live from the Takeo training room here in Cranston, where I'm at right now. I commandeered our trade show coordinators office right now, so she's out at the moment, so I stole her office, so she doesn't know it yet. She will know probably by the end of class.
There you go. Well, clean up after yourself, for God's sakes.
Yeah, I know, right? So everybody, thank you very much. Unfortunately, I do not know what next week's class is, but the commercial team, Rich, Brett, and Tony, will be taking over and running with the Takeo Tuesday classes again. So, and I don't know what the next residential one is coming up. So, but anyway, everybody, thanks for joining us today. JB, thanks for joining as well. All right, good to see everybody out there. See you soon.
See you tomorrow morning. Not you people. I'll see Dave tomorrow morning. There we go. Let's get that straight. So long, everybody.
See you.